Hello class. This video is going to focus on 1.2 algebraic expressions. The goal of this video is I can write algebraic expressions for verbal expressions, and also I can evaluate algebraic expressions. So you want to open your textbook to page 15 so that you can take notes. We are going to start with example 4 on page 15. Write an expression. So when writing an expression to represent a situation, choose a variable to represent each unknown value in the problem. This is called defining a variable. So we have a soccer problem. In the group play stage of the FIFA World Cup, teams are placed in groups of 4 and they play each other. A team is awarded 3 points for a win, 1 point for a tie, and no points for a loss. Write an algebraic expression that represents the number of points accumulated by one team in the group play stage of the World Cup. Okay, so we need to define variables for the unknown values. So we're going to let W be the number of wins, T be the number of ties, and Z be the number of losses for one team. So the number of points awarded for wins is 3. And then that's going to be times W, so 3 times however many wins. The number of points awarded for ties is going to be 1 T. You could also just say T instead of 1 T. And the number of points awarded for losses is 0 Z, or just 0. The number of points accumulated then is going to be 3W plus 1T plus 0 Z, or 3W plus T. So since 1T and T are the same thing, I just wrote T. And then 0 times Z, 0 times anything is 0, so it goes away. So A, we want to write a verbal expression for the number of points accumulated and interpret the meaning of the variables in the context of the problem. So if you remember, we have 3W plus T. And I'm just writing it down because I have it on the last screen. You guys still have it in your book, so you don't need to rewrite it. So if we want to write this verbally, we can have 3 times, so W is the number of wins, so 3 times the number of wins plus, and then our T is the number of ties, so plus the number of ties. Okay, so that's our verbal expression. B, what units are associated with the variables, the coefficients, and the expressions? So for our variables, we have W, which is wins, number of wins. We have T, which is number of ties, and then we have Z, which is number of losses. So those are the number of games. So variables, those equal number of games. And then the coefficients, those are the numbers that are in front of the variables. So we have 3, which is how many points we get for a win, 1, which is how many points we get for a tie, and then 0, which is how many points we get for a loss. So those are the number of points per game. And then the expression itself is the total number of points that we get during the bracket play. So expression is total amount of points. And then C, how would the expression change if a point were deducted for each loss? So this is saying instead of having 0 Z, now we're going to have minus 1 Z every time we lose. So that would change the expression. So we would have 3, we still get 3 points for a win, plus 1 point for a tie, so plus T. And now instead of having nothing on the end, we would have to subtract 1 Z, or 3W plus T minus Z. So this would be the most simplified way to write it. Okay, we are on page 16 in the notes. We have algebraic expressions can be evaluated for given values of the variables. The substitution property allows us to evaluate an algebraic expression by replacing the variables with their values. So the substitution property, in words, it means a quantity may be substituted for its equal in any expression. So anytime we have a variable, if they give us a value for that variable, we can substitute that value in place of the variable. Okay, this is example 5 on page 16. Evaluate an algebraic expression. So we want to evaluate 8 squared times the quantity 3b minus a plus 5, all divided by c. Now, the thing we have to remember is, number one, we're going to substitute our values in, but then after that, we have to use order of operations in order to evaluate it. So I'm going to start by substituting. So we have a squared. Anytime I see a, I'm going to put a 2. Anytime I see b, I'm going to put a 6. Anytime I see c, I'm going to put a 4. Okay, so starting with a squared, so that would be 2 squared. And then I have parentheses. And then I have 3. Now remember, anytime you see a 3 in front of a variable, that is multiplication. So we're going to do 3 times b, which is 6. So times 6 minus a is 2, plus 5, and then divided by c, which is 4. Okay, so this first step was just substitution. Okay, now we're going to start to actually evaluate. So using PEMDAS, we start with our parentheses. So inside our parentheses, we've got multiplication, subtraction, and addition. So I'm going to start off by multiplying. So I'm going to bring down 2 squared. 3 times 6 gives me 18. And then I have minus 2 plus 5, and then divided by 4. Okay, I'm still inside my parentheses. So now I'm going to do my subtraction before addition since it comes first, going from left to right. So 2 squared comes down. 18 minus 2 is 16. Bring down plus 5, and then divide it by 4. Okay, now we're going to do 16 plus 5. So I have 2 squared, and then times 16 plus 5 is 21, and then divided by 4. Okay, so now I have an exponent, I have multiplication, and I have division. So next we're going to do e, which is exponents. So 2 to the second power is 4. I'm going to write it over here. So 4 times 21 divided by 4. Okay, so now I have multiplication and division. So I do multiplication next. 4 times 21 is going to be 84. And then divided by 4. And then we're going to do 84 divided by 4. And that's going to give me 21. Okay, so my answer is 21 when I substitute all those values in. Okay, we are going to do this check together. So this is still on page 16. So evaluate b times the quantity 9 minus c all divided by a squared. So again, we're going to substitute 4 for a, 6 for b, and 8 for c. Okay, so we're going to start off with b, which is 6. And then we have parentheses. And then 9 minus c, which is 8. Close your parentheses. And then on the bottom, the denominator, we have a squared. So that would be 4 squared. Okay, so we're going to start off with our parentheses. Actually, I'm going to do two things at once. I'm going to do the top and the bottom. Okay, so we're going to do 9 times 8. So that's going to be 6. 9, oh, sorry, not 9 times 8. 9 minus 8. 9 minus 8 is 1. So that's 6 times 1 on the top. On the bottom, I'm going to do 4 squared. 4 times 4 is 16. And then on the top, 6 times 1 is 6. On the bottom, we have 16. And then we can reduce that. You can use a calculator to reduce. So we can divide both of these by 2. 6 divided by 2 is 3. 16 divided by 2 is 8. So 3 over 8 is my simplified answer. Okay, example 6, this is on page 17. We want to write and evaluate an algebraic expression. So world records. In 2004, Chad Fell set the record for the largest bubblegum bubble blown. Assume that the bubble was spherical, that is a 3D circle. The surface area of a sphere is 4 times pi multiplied by the radius squared. So they gave us a formula. So in part A, we want to complete the table to write an expression that represents the surface area of a sphere. And then in part B, the record setting bubble had a radius of 25.4 centimeters. Find the surface area of this bubble. Okay, so part A, complete the table to write an expression that represents the surface area of a sphere. So in words, we have 4 times pi multiplied by radius squared. So for our variable, r is going to be the radius. And then our expression is 4 times pi r squared, or 4 pi r squared. Okay, in B, we want to find the surface area of this bubble. So that means we need to substitute. So in place of r, which is our radius, we're going to actually put 25.4. And then we need to do 25.4 squared. Sorry, I don't know why that looks like a 2. It should be squared. And I'm going to use my calculator to get my answer because I know what 25 squared is, but I don't know what 25.4 squared is. Okay, so when I calculate 25.4 squared, I get 645.16, which I actually did know it because it says it right there. Okay, so next we're going to multiply 4 times 645.16. And again, I'm going to use my calculator. And I get 2580.64. And that all is multiplied by pi. And then you can multiply 2580.64 times pi, and you're going to get an answer that is approximately 8,107.32. So the surface area of the bubble is approximately 8,107.32 meters squared. Okay, that is the end of 1.2c. Again, you will have your quiz over this video coming up shortly. You must get a 75% in order to move on from the video.